Okay, hello guys. Yes. Let me check. So, what I want to do for this today's? Yes. Okay. Very nice. This paper presents an end-to-end deep learning regarding neural networks. Okay. These papers. This paper represented Khmer's Khmer handwritten. This paper also represented Khmer handwritten recognition image text line. This paper represents Khmer handwritten recognition text line. OCR, yes. Đặt bật ấy pro này. Bot chắc. Yes. This paper represented my handwritten resignation. Text line OCO. Yes. Like okay. Dương vô changeពី presentation យើងខ្លះមក what I want to do man pause previous message this paper represented my handwritten resignation this paper present end-to-end deep convolution okay giờ ai đã trong đây this paper represent thì vô má chầm cài tam khỏi class má I want to change something yes which format so this paper is like this paper represents end-to-end like end-to-end T or OCO stand for transformer T or OCO full form transformer based obstacle okay where is it okay I will pass it here yes okay so this paper present an end-to-end TOCR transformer based optical regulation architecture yes architecture solution for my handwritten handwritten like resignation task yes these papers represent the yes landscape right okay that's fine
hôm nay nó cái cái rồi
này
có sai đau với mình đó
sai đam viên làm nền
Tại đâu phân cái này.
Recommend A4.
Một cái file gì?
Chọn. Why it doesn't work? Your iPhone. So I'm gonna be. If I was to pass this one, this might be girls. This one. Yes.
Mong tin người ta nói vô cam gì rồi kìa.
Yes.
Đi qua mà nhận được quyền.
Để vô anh đúng không? Đấy đây. Yes. Yes.
Jangan main dari kaki, nilai tu satu yang baik. Yes.
The spent pairs represents an end-to-end like TOR transformer-based optical recognition architecture solution for Khmer 110 recognition tasks. Compile môi abstract những ai GPT chui từ xe abstract style mà please write it as abstract style for Latin document yes, abstract styles, yes. Abstract styles have some abstract style is have some text style. No text style for abstract. Text style for abstract. Yes, text style for abstract. Just a thing. Yes. Please add some this one. Okay. Selection. Compile again. Nhưng chọn ở cái thread một tích sẽ liền chết. Abstract style. Abstract. Style. Yes, okay. slide. Abstract. This paper presents end-to-end like TROCR transformer based optical character recognition architecture. Dương praដូចជា TROCR with DEIT. How can we represent? How can we write it? This paper presents end-to-end solution for Khmer handwritten using a hybrid. No, it's not. It's not hybrid. How many types of TROCR based on my research have some with VS DEIT and how it's related to TROCR. In realm like transformer-based optical character recognition, there are primarily two main models architectures. How is related to TROCR. Okay, so TROCR with there are primarily two main model architecture that serve as a region transformer for OCR transmit, and both with and DX can act as the encoder for TROCR, contributing different strain to the OCR pipeline as breakdown. This original vision-based transformer model designed to process image using a patch-based approach with divided image into patches, embed them into sequence and process. This sequence as a transformer would be an LNP task with when integrated with TROCR. When integrate with TROCR with serve as the encoder for OCR pipeline. The TRO model uses this encoded image information to recognize text and enabling effective end-to-end OCR tasks. Strange with offer high accuracy for tasks with large dataset given that is was initially trained with considerable amount of label data, it particular effect in capturing long-range dependencies within the visual features of images, which is advantageous for complex and diverse handwritten script. He also within data efficient image transformer is more resolve effect gradient of with designed to work effectively on smaller data set without a heavy dependency on label data. The EIT achieved this through techniques like data augmentation and distillation with teacher models, which improve performance on raw data regimes. When paired with IT or OCR, the EIT serves as an efficient and powerful encoder that processes the input image for OCR tasks with fewer label data requirement. This is particularly beneficial for OCR tasks with low resolved languages like Khmer written via unthreaded data may be limited strength, reduced need for extensive data making ideal for domains with limited resolve. Modular encoder choice in OCR, the encoder component responsible for converting image patches to token embeddings can flexibly use either depending on the dataset and data constraint. Performance effects trade-off which provide higher accuracy with abundance of data. While they offer more practical solution in data constrained environment, there's also flexibility in selecting between width and it allow researcher and practitioner to balance between accuracy and efficiency. Application to complex script both with and the EIT contribute to the recognition accuracy of complex script such as Khmer by enabling us to capture detailed visual pattern given in challenging handwritten. So you mean that with and the EIT and all for encoder and T or OCR and all for the coder. Yes, exactly. T or OCR architecture. It may serve as the encoder, and while the T or OCR framework include transformer-based decoder specially designed for optical character recognition tasks. Here breakdown with encoder. The encoder process input image divided into patch, embedding this patch and passing them through transformer layer. This step extract meaningful feature from image, encoding visual information to sequence embeddings, which perform well with large dataset, capturing data, optimized data vision, performing well on smaller data, which makes it great for low resource OCR tasks. The decoder in the OCR task, the encoded embedding from the encoder and convert them into text. It's designed to model sequence of character. Please explain TR OCR with and with the IT architecture step by step. Please compare VIT and DIT. Both architecture are designed for image processing using transformer module but differ in terms of efficiency, transparency, and performance. With TLS or with vision transformer, patch linear. Transformer and encoder. TLS with data efficient image transformer, step by step, like train from scratch online data set, use teacher student setup for improved efficiency. Require light data set to perform well, with less data. Good, but can improve with more data, better performance, smaller data transferring extension. Architecture complexity, general, straightforward, more complex due to teacher-student model. Teacher-student models. Yes, teacher-student models. No, like distillation steam models. Knowledge distillation refer to the process transferring knowledge from a large model to a smaller one. This is vital because the larger knowledge capacity of bigger model may not be utilized to fit its full potential on its own. Even if the models only employ a small percentage of its knowledge capacity, evaluating it can be computationally expensive. Knowledge distillation is the process of moving knowledge from a large model to smaller ones while maintaining validity. As illustrated in the figure above, knowledge distillation involves a small student model learning to mimic a large teacher model and use the teacher knowledge to achieve a smaller and superior accuracy. The size of neural network is enormous. Knowledge distillation. To understand knowledge distillation work in real life, let's take the example of self-driving car. The deep learning model used in the image recognition system for self-driving cars, which is based on the convolutional network, has a very high accuracy rate, but it's too large to be deployed in the car themselves due to computational and memory requirements. To overcome these issues, knowledge distillation can be used to transfer the knowledge learned by the CNN to a smaller, more efficient model, such as the mobile net and squeeze net. These still models will be trained to mimic the output of the CNN on a set of lapel training image. During training, the loss function will not only consider the difference between the output of the distill model and the true lapel, but also the difference between the output of the distill models and the output of the CNN for the same input. This one best knowledge. Distillation, self-distillation. No way, why? It's so hard, man. Complicated to understand. It's really complicated to understand all of these things. Oh my god. That is insane. You know? Yeah. You know that is insane. Oh my gosh. It takes time to understand this, you know. Yes. Utilizing teacher-student models. Oh my god, teacher-student model. How can I go to understand this? Maybe I need to watch some YouTube video, you know, knowledge distillation. Let me go to understand all this knowledge distillation in deep learning. Okay. Let's explain me.
This is David, and in this video we're going to explore the concept of knowledge distillation deep. What is knowledge distillation? Well, it's a compression technique used to make large deep learning models smaller, faster, and more efficient. Let's just look at this graph for a while. These are all new deep learning models in NLP, and you can see the number of parameters are increasing as we progress through the timeline x-axis. The top companies are on a constant race to bigger and bigger models, thus beating the state-of-the-art accuracies. So what's wrong with bigger models? Well, getting more resources to run. Inference time can be expensive, especially if you are planning to deploy these on non-GPU machines. These models will be harder to fine-tune and manage them. That's why we have this awesome concept of knowledge distillation, which is used to reduce the size of models. Before we go any further, let's just look at this neural network, which classifies the input image into three classes: deer, a horse, and a peacock. Now look at the predicted probabilities and the actual labels of this image. Just look at these numbers and which of these actually gives more information. What does this actual probabilities tell you? Well, the input image is a deer, and it is not a horse, and it is not a peacock. Now look at what predicted probabilities tell you. I think it's a 60% chance that there is deer, but there's also a 39% chance that it's a horse, but with only 1% chance that it's a peacock. So this kind of is giving you more information on this input image. Why did it also give a 39 on horse? Because the structure, body shape of deer and horse are kind of similar as compared to the deer and peacock. So comparing the actual labels and the predicted probabilities of a trained neural network, we could always say that the predicted probabilities that are coming out from the neural network is having richer information than the actual one-hot encoded labels. Now the concept is, what if we take these rich information and teach a new network? So let's just keep that in mind and try to understand the knowledge distillation setup that we have right now. Typically we have a teacher and a student. Teacher model is typically a large pre-trained model or an example of large pre-trained models, which has been trained on lots and lots of data. And then we have the student model, which is a newly small model. So what we do is we take the training data and we have the hard labels, which is basically the one-hot encoded class labels. We take the training data, we feed it into both the teacher and the student. We get the predictions from both these models. Now the predictions from the teacher model, as we saw in the previous slide, has lots of valuable information. These predictions come as distilled knowledge and adds as a component in the overall loss that we calculate for the student model. And then we calculate this loss and then backpropagate this loss on the student model. Remember, the teacher model is weights are frozen, so we're updating the weights in this model. We are already updating the weights in the student model. So the component in the overall loss that we calculate for the student model. And then we calculate this loss and then backpropagate this loss on the student model. Remember, the teacher model is weights are frozen, so we're updating the weights in this model. We are already updating the weights in the student model. So to understand how this loss works a little bit more deeper, let's just review softmax activation function, right? So let's just assume this is the output that is coming from the final layer, and softmax activation function just takes all these values and converts them into things that we can view it as probabilities. It's just taking these numbers, raising it to the exponential, and then normalizing by maximum temperature things, and then we do this thing. So these are the final layer logics. 0.5 to 1 minus 0.5 is same. These values are fed into this softmax with temperature, and then we get something like this. So when t equal to 1, it is as good as our softmax function. So we have the class with the highest value gets the highest probability, and the rest of the probabilities are very low. But like when I increase t to 0.59 got reduced, and the rest of the things got increased. So it's as if like the class with the highest probability is reducing a little bit, and the rest of the classes are increasing a little bit. So it's kind of like smoothing. So let's see how this loss is calculated, which is used to train the student model, right? So we have the logics for the student and logics for the teacher. Logics are the final layer output values, which is expressed in this form of vector. So we have V for student, Z for teacher. We take the softmax with temperature formula, and then we apply this vector on this softmax to get P and Q vectors. Once we get these values, we also take the hard prediction. So hard prediction is calculated only for student, which is basically you take the P vector, get the highest value, set it to 1, and set the rest of the values to 0. So it's like looking at the class probabilities, but setting the highest class to 1 and the rest of the classes set to 0. So we have the hard predictions, and then we calculate two types of loss. So let's look at what those losses are. So loss 1 is based on soft targets, and that is basically the cross entropy between Q and P. So these are called soft targets because they are coming through the temperature functions. You take the cross entropy between these two. So it's almost as if like this is your Q is your true probabilities and P is your predictions. So cross entropy is computed like that. Then you have the loss coming from the hard targets, which is the cross entropy between the student predictions, which are the hard predictions, and y true. Y true is the actual one hot encoded class labels. So we take the hard targets and get a cross entropy over there, and then we take the final loss as a weighted average of loss 1 and loss 2. So alpha is some weight here, and we take the weighted average of loss 1 and then 1 minus alpha and the loss 2. So all these values like alpha, t are kind of hyperparameters which we can adjust accordingly. So once we have the loss like this, we back propagate these loss into the student model and retrain the student model. So this is just if you want to review the cross entropy. This is the formula for cross entropy. It's always computed on a true label versus predicted label. So the true label into the final distillation loss, which is the weighted sum of loss 1 and loss 2. And this way, you train this student model under the guidance of the teacher. Why did I say under the guidance of the teacher? Because the teacher is also contributing something to the loss. It's contributing rich probabilities which actually capture the data distributions of the input data set. And then that's fed into the student model. I hope you got a basic understanding of how this works. In the next videos, we will be definitely looking into deeper and understanding how these are actually.
I have a question. Person by model បើសិនបើនៅលើភាសាខ្មែរវាយើងអត់មានរបៀបថាអត់មានខ្មែរ handwritten pre-trained model ថាអា distillation របស់វាហ្នឹងនៅតែជួយចង់ថា teacher ហ្នឹងវានៅតែជួយដើម្បី find loss ទៅកាន់ student ទៀត So I want to ask something like how about we haven't you know yes example how about we haven't pre-train on large data set model is that current we haven't pre-trained on like data set. We haven't pre-trained. We haven't pre-trained on like data set of Khmer language, but only English language. Is that the teacher model still have student to learn more effective way or not? Yes. When consider use of teachers student models, particularly in the context of tasks like obstacle for such as Khmer language, which may not have a large pre-trained data set, there are several important aspects to understand about effectiveness of transfer learning and model adaptation.
Lời stand by đưa luôn.
Không ra nữa nè. Mình quay mà đã xuống mình.
Vâng ạ.
Ngay trở cái điều đó sao?
Chưa rồi.
Sao nè?
Vâng rồi, bảo sư.
Kỳ lần kỳ thét cho mấy chú má này.
Chắc đang phải ăn sao?
Yes, that's But actually, cái presentation.
Đúng không? Mà là ai để ý được ai thì không có điều mấy mà luôn đấy. Anh mẹ đại phát hả? Về đi chọc ấy thơ ca như ấy.
Thế
Về nâng nè anh chứ.
nè. Cái tập đi.
Trong đi tiếp đấy chứ.
Tập đi theo.
Ê, không quay đấy.
Nói không luôn đi này. Được, chẳng biết là theo. Yes, bye bye.